Good day, everyone. I'm here in front of you to discuss about transformation, geometric transformation of shapes. So, I will going to discuss about geometric transformation of shapes, its different types, and also give a real life examples of it. So, here are the different types of geometric transformation. Translation, reflection, rotation, glide reflection, enlargement, and reduction. So, transformation. What is geometric transformation? Geometric transformation is describe how a shape changes in position, size, or orientation. It is widely used in fields like architecture, engineering, animation, and even in nature. Transformation help in understanding symmetry, movement, and resizing in real-life applications. So, a transformation involves an object or an original object in an image, new shape after the transformation. So, these changes can be in different form of movement like flipping, rotating, or resizing.
Go. So first type of geometric transformation, which is translation. So what is translation? Translation signifies move a shape from one position to another without altering its size, shape, or orientation. So in every point in the shape moves the same distance in direction. As you can see in the image, X and Y. So the first orientation or the first position of the shape, which are which is the X, was moved to the position now of Y. So as you can see, the shape or the size was not altered. However, the position was changed. So that is translation. So here are some examples of translation. First example is moving a book across a table. So just like in translation, the book shifts in position. However, it doesn't change its shape or size. It's still the same book that you move. It's still the same size of book that you change position. So second example was a train moving forward follows a straight path, similar to how an object translates in geometry. So a train moves at a very high speed. However, it doesn't change its size or its orientation. However, the position of the train will go to move forward or either backward. Go.
The second type of geometric transformation of shapes is rotation. Rotation turns a shape around a fixed point or the center of rotation by a certain angle. The shape remains the same, however, its position changes. As you can see in the image, so the triangle A was rotated and suppose that's one.
Go lang.
The second type of geometric transformation of shape is the rotation. Rotation turns the shape around a fixed point or the center of rotation by a certain angle. So the shape remains the same, however, its position changes. As you can see in the image, the triangle A was flipped or rotated and now become triangle B. So here are some real life examples of rotation. A Ferris wheel rotates around a central point, just like how a rotation works in geometry. So the Ferris wheel was moving like this, so it was rotating. However, it was not moving because it has a very in the middle of it. Second example is the windmill blades turning show how objects rotate at a fixed center. So just like the Ferris wheel, they are rotating. However, it doesn't move away from its original position. The third part of the transformation of shape is the reflection. So reflection creates a mirror image of the original shape across a line of symmetry. So the shape does not change in size, but it flips the symmetry across
transformation of reflection. So first one is a mirror reflection creates an identical but flipped version of itself, just like geometric reflection. So as you can see in the mirror, so um, it was you, it was an identical to you, however it was flipped. So second example is a butterfly wings are symmetrical, meaning one wing is a reflection of the other, just like in our lesson one in the MMW, we talked about patterns. So as you can see, a butterfly wing, if you have it in the middle, so if you will going to um, put it in the other side, it will still the same because it was mirrored or symmetrical. The fourth example or the fourth type of geometric transformation in shape was the line reflection. So the shape moves in one direction and then flips across a parallel line. So it was a combination of translation and reflection. So it was changing its position and it's still reflecting to the other side. So the example of this in real life situations are, for example, is footprints in sand show line reflection because each step from forward moves forward. So it moves forward, example of translation, and leaves an opposite print, which is an example of reflection. Second example is floor tile patterns often have repeated shapes such as plate and reflect to create symmetry. So just like example number one, first was the floor tile was repeated, so it was translating and reflected because it has a axis of symmetry, so it creates symmetry.
The last type of geometric transformation of shape is the dilation, or also known as the scaling transformation. So dilation changes the size of a shape without altering its proportion. So it has a scale factor that determines whether the shape will be enlarging or zooming and reducing or zooming out. So scale factor, if it's greater than 1, it is an enlargement or enlarging. If the scale factor between 0 and 1, it is an example of reduction. So unlike the first four was altering its position, its um, flipping, like the reflection and light reflection. Dilation was more likely zooming in or zooming out, changing its size and proportion. So example of dilation was zooming in an image enlarges it, while zooming out reduces it. So just like in dilation. Example two is resizing a logo. So as you resize the logo, you could have a different format without distorting its original shape. However, you could resize its size or proportion. Under the dilation, there are two types of geometric transformation, which is reduction first. So a type of dilation where the image was smaller than the original object, so it was zooming out. So example of this in real life situation is the miniature models of buildings used to use reduction to create a smaller proportional replica. So, as an engineering student, we use replicas to create a smaller scale of the building that we want to recreate. So, example two was reducing the size of a blueprint follows the same concept of scaling down while keeping proportions intact. So, for example of this is the original size or original measurement of the building was 100 feet. So we were going to reduce its size to every feet for 1 centimeter. So we are going to ratio or scale it in a lower unit. The second type of dilation is the enlargement, or also known as zooming in. So zooming in, a type of dilation where the image becomes larger than the original uh, image. So example of this is projecting an image on a bigger screen. Enlarging it similar to how enlargement works in geometry. So for this example is um,
I'm using a PowerPoint presentation, so I have a laptop here and a big screen. In the laptop, it has a smaller text. However, if you can see in the screen, it becomes larger. So it is an example of enlargement. The second one is an artist magnifies a small drawing to create a mural demonstrating dilation with a scale factor greater than 1. So, for example of this is if you have a hard copy of the drawing or even in a soft copy, if you have an image, then you are going to create a mural. The image on what you are going to make is smaller than the what you are going to create in the mural. Geometric transformation or geometric shape transformation in real life application. Um, Example of this is an architecture in engineering. So geometric transformation is used in engineering for symmetry in structures, like resizing blueprints to create a different size model. So resizing a blueprint is an example of dilation. It could be reducing or enlargement. In animation and gaming, it is also used when there is a moving character, which is an example of translation or rotating object. Also, it is used in resizing elements in digital art. Art design, it reflections in graphic design in enlarging or reducing images for different purposes. So, reflection, it could also be light reflection because it is kind of reflecting and as well as translating. And also in nature, the symmetry in butterfly wings, wind crystal formations, and waves. In conclusion, geometric transformation help us to understand the move. In conclusion, geometric transformation helps us understand movement of symmetry and size changes in objects. The four basic types are the translation, rotation, reflection, and glide reflection. If we include the dilation, including the reduction and enlargement. So these concepts are widely used in real life, and mastering them enhances problem solving skills in various fields.